Let us talk second moment of area. If we have an object like this has got a rectangular section, you'll notice it's a lot easier to bend it this way than it is to bend it that way. And why is that? And that's because what happens is that the strength of the moment, or the moment of inertia, is dependent, if we're bending it looking end on, whether we're bending it this way, applying a force that way, or we're applying a force that way. So what we have to do is, when we're doing engineering, we have to take into account not only is the shape important, but also the direction the force has been applied. And also, if we're building a structure, if we can take this further, if we take a piece of steel and we turn it into an I-beam, it's the same amount of steel, but suddenly it's stronger. Even though the area here is meant to be the same as the area there, this is a lot stronger. And this is because if we work out where the centroid is here, if we draw a centroid line, the part of the strength of the structure depends not only upon the amount of steel, or the aluminium or whatever, but how far away we can get it from that line. And this is the second moment of area. So we have to take, when we're working out second moment of area, we have to work out the amount. We have to basically break each one of these things up into sections, and then we have to work out the moment of area. So we call it Ix, is the second moment of area, or the area moment of inertia, is going to equal, notice I prime, I'm going to call this I prime, the inertia of each individual bit, plus then we work out the area, just like we were doing for centroids, and the distance that is from the centroid. And we're going to square that. We'll call that ADY because that's the distance up. So let's actually try and think about this a bit more. So this is the general formula. We break it up into bits. We work out the second moment for each bit, and then we add on a bit for how far away that is from the centre of our structure, or the centroid. Now the question is, how do we work out Ix, or I prime X? And well, there's a couple of ways we could do it. We could look it up. We could work it out rectangle, for example. We're going to make that the depth, and that's the breadth. So this we're going to be in respect to here. So we're trying to figure out. We can then integrate that lot, equals integral of blah 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 dx. Or we could just go to a book and look it up. So for a rectangle, we can just go to a book and we look it up, and it's going to be the breadth times the depth cubed, or basically the height of the block, divided by 12. That's what all the integration will do. Okay, for a triangle, so remember, this is D, this is B. For a triangle, Ix equals triangle. This is going to be D, this is going to be, it's going to be B, D cubed over 36. For a circle, Ix equals, well, it's going to be the radius of the circle, it's capital R, so it's going to be pi times the radius to the power of 4 over 2. And if we're going to do a tube, say we were doing a tube, R is going to be to the outside wall, little r is going to be the inside wall, I prime equals pi r to the capital R, the outside diameter, minus the inside diameter, or each of those to the 4th over 2. So, and I mean, you can look it up for pretty much any basic shape. You can go to a book and look it up. If you're going to do more complicated stroke bits, like an I-beam, we'll break it up into simpler bite-sized chunks, work out this bit, and we'll add it up. So let's actually look at the steps of actually doing this. If we were going to do, say, let's imagine I'm going to do a T-section. T-section all in millimetres. And let's make this, I don't know, 200 by 20. Obviously this is not to scale. This is 200 to 20. We're going to break this up into several steps. Step 1 is break into simpler shapes. And this is to find the second moment of area. Step 2 is work out the centroid of the system of the compound shape. Step 3, we're going to work out the second moment of area, I prime x, of each bit. And then using that, we can then work out ix equals I, we just worked that bit out, plus a cube, and then finally add up all the ix, and that will give you the final amount for the total system.